Good afternoon, girls.
Good afternoon, teacher.
Good afternoon, teacher.
Okay. Yes, I'll call upon one of you to lead us in word of prayer. Then after our main teacher will take over.
Go and pray.
Prayer.
Lord God, Father, thank you for the gift of today. Thank you for everything. We pray that as we are studying chemistry, we may understand everything and excel. In Jesus' mighty name I've prayed. Amen.
Amen.
I hope your day is good, young ladies. Can I get any responses? Are we well and ready for the lesson?
Yes.
Yes, teacher.
So we are
Yes,
very ready. We are ready.
You have done some more reading about this topic and done some practice. I hope all of you have those books of revision chemistry. That is a firm foundation in chemistry. If you check that book, it has quite a number of examples about writing formula. We are taking more time on this because we want you to go ahead. We shall be writing equations, writing formulas. So if you get this foundation quite well, it becomes easy for you as we proceed in the other topics in chemistry. So I hope you're doing yourselves are a good job by making sure that you do many examples. So on my screen, I have quite a number of examples that we shall go through, probably not all of them, but we shall go through some of them. And if time allows, we shall introduce how to write equations as well. Teacher Martha?
Yes, teacher Silver.
Teacher Martha, can I? Yes, please.
Okay, you can proceed.
Okay, I don't know if you're ready to do the lesson or I can go ahead and teach. So on my screen,
Sodium carbonate.
sodium carbonate. I'll be using the board as you also respond. So can someone tell me the formula for sodium? What is the formula for sodium?
Na.
The symbol for sodium. Okay? So sodium is Na. What about a carbonate?
CO3.
So you copy the all of it. It is CO3. Because that is our first step, we write the symbols. After we have done that, our next question is, what is the valency of sodium? What is the valency of a carbonate? Can I get responses? Valency of sodium, valency of carbonate.
The valency of sodium is 1.
What is the valence?
Balance.
Then a carbonate.
2 valency of
2.
That means I have 1 here and then 2 that side. We interchange the valency. Someone has a question?
No, teacher, I was just asking if you are writing this down.
Yes, please, you need to write it down.
Okay, thank you.
I said I'll go through some of the examples and not all of them, but some of them. So after interchanging the valencies, that means that where sodium is, I have a 1. But if you remember, we don't write the valency of 1. So that means my final answer is going to be sodium, which is Na, the 2, which is there, and then a carbonate. As that. Remember, when we are starting, that is when we show the working. But if I tell you, write for me the formula of sodium carbonate, I only need to see the final answer. I don't need to see the working. I hope we still take note of that. Can I get someone taking me through the formula number 2? I'll be writing as you tell me what to do. Daphne, yes?
So I was saying that the blackboard is not.
Daphne, did you have a question?
So I was saying that the
The blackboard is not clear. Is it clear now?
No.
Can we see what is on the chalkboard?
No, teacher.
Yes.
No.
Not clearly, teacher.
maybe the lens is blurry.
Teacher Silver, your mic is muted.
I'm asking, can we see what is on the board now? Or still we can't see it?
Teacher, it's a bit blurry.
Not clear.
We can see, but it's not clear.
That's how I've understood.
Clear.
get to the person who was putting up their hand to show me how we write potassium chlorate. That is Johanna.
Yes. So we write,
Yes.
first write the symbols.
What is the symbol of potassium?
Ka and chlorate ClO3.
Ka.
Yes.
Potassium is Ka, Johanna.
Oh, sorry, it's K. K.
Sure, just K.
It is only K. Then the chlorate. Then the
ClO3.
chlorate.
ClO3.
Can you proceed to the next step?
And then you write their valencies above, and the valency of potassium is 1, and so is chlorate.
What's the valence of potassium?
1, and so is the valency of chlorate.
Then the chlorate.
1. And
Next step.
you interchange the valencies, but because it is 1, we ignore it, and it remains KaClO3.
Okay, thank you very much. I hope all of us have taken note of that. Carbonate. Yes, Petra. Petra.
And the one for carbonate is CO3. And then the valency of calcium is 2. And then the valency of the carbonate is 2 as well.
2, yes.
So we interchange the valencies. And since it's 2 and 2, we can reduce them. We can reduce them to get the simplest factor. So it will be, you divide 2 by 2 and you get 1. So it will be CaCO3.
Thank you very much, Petra. I hope all of us are following. I said we'll do these numbers by ourselves. It is very important that we do practice. So that is how we write calcium carbonate. Okay, and can I get another person taking us through magnesium nitrate? Magnesium nitrate. Yes, Ndagire.
Yes. The symbol for magnesium is Mg. And then a nitrate is NO3.
NO3, yes.
Then the valency of magnesium is 2. And the valency of a nitrate is 1.
Yes.
So then we interchange the
Proceed.
valencies as Mg NG, then in brackets, NO3, then the 2 on the outside. Three, then
I hope all of us know why we put the brackets. We said if a radical is made up of more than one element, we put everything in brackets and then put the valency outside. I hope we note why we are putting NO3 in brackets, because the 2 is for the nitrate. And when you put it on only oxygen, that would not be right. So we put it in brackets and put the 2 outside. Daphne, do you have a question?
Not chanted. Answer the next one.
Daphne, any question?
No, teacher. I
You want
wanted
to
to
do the
answer.
next step?
Yes, teacher.
Teacher, I have a question.
Was a question that is Destiny?
No, Johanna. Um,
Yes, please.
my question is, so you only you use brackets the when the radical carries, let me say, a number after the chemical symbol.
If it carries a number after a chemical symbol, you mean like NO3? When it is the 3 is the one that you're talking about?
Yes.
Not really, because not only that, if I had OH, for example, it doesn't have a number on it, but it is a radical which is made up of 2 elements. Let's say if I have copper 2 hydroxide, and I'm writing that compound. Remember, copper, that means has a valency of 2. The hydroxide has a valency of, when I interchange, I'll have 1 for copper and then a 2 for the hydroxide. So still, I put the hydroxide in brackets, even when it doesn't have a number. As long as the radical has more than one element in it, we put it in brackets if we have any figure to write on that radical. Is that okay, Johanna?
Yes, thank you.
I don't get your response, Johanna, but I hope you have answered your question. Destiny?
No, teacher. I just wanted to answer the next.
Destiny, do you have a question?
No, teacher. I just wanted to ask.
What did you say when you were saying that the nitrate has to be in brackets, like the 2 has to be outside and
Nitrate is NO3. So the 3 is part of the symbol for a nitrate. But after exchanging the valencies of magnesium and a nitrate, I'm supposed to write a 2 on the nitrate. So I can't just put the 2 anywhere. I have to first put the whole of the nitrate in the brackets, and then you put the 2 outside the brackets. When you put it outside, it means it is taking care of the nitrogen, it is taking care of the oxygen. Is that okay, Msimenta?
yes, teacher. Thank you so much.
You're welcome. Can I get the person who said they want to do number 2? That is, they want to do number 5.
Me. Teacher, me.
it was Destiny.
I said first.
Yes, yes.
So first to write the symbol for sodium and hydrocarbonate. Na and HCO3.
Yes.
So the valency for sodium 1 and the valency for a hydrocarbonate is
1. The next step.
the valency is 1.
Destiny, what is the next step?
So
Then for
that's
the hydrogen carbonate?
Is 1.
Yes, Daphne. Can you
So
proceed? How do we continue from that point?
we interchange the valencies, which gives us, so we don't write 1, so which gives us NaHCO.
Thank you very much, Daphne. If we have questions, I said we'll not do all of them. We shall pick some. So can I get someone doing for me? Can someone do for me number 7? That's ammonium chloride, number 7.
Yes, teacher.
Can you go ahead?
Ammonium chloride. So the chemical symbol of ammonium is NH4. And the
Yes.
chemical symbol for chloride is Cl. The valency of is 1. And the valency of chloride is 1.
Next step.
We exchange the valencies and the answer will be NH4.
Why do we have NH4? Why aren't we writing the ones? Can you remind us?
Because we don't write a 1 in chemistry.
Thank you very much. So that is the formula for ammonium chloride. Okay, can I have someone doing for me number 8? Number 8, today I said we are doing these numbers to give us more practice. You have a question?
Yes. Yes, I was asking that what if they...
Yes, please, go ahead.
That what if they ask us to find the radical, to tell the radical? Do we give both ammonium and chloride?
In this compound of ammonium chloride?
Yes.
Yes, both of them are radicals. So that is what you would give us. Ammonium is a radical, and then the chloride is a radical.
Okay, thank you.
Lindsay, do you have a question? Or you want to answer?
I want to answer. Number 8.
Please go ahead.
So the first procedure
Go
is
ahead.
writing the symbol. Yes, we write a symbol. For hydrogen is H.
Yes.
And then chloride is Cl.
Can you proceed?
Cl.
Yes.
And then the valency for hydrogen is 1. And for chloride is 1 also.
Yes.
We interchange the valencies and then we have HCl.
Thank you very much. Lindsay. Is following, we said you need to write these examples in your book and get used to writing them, because as we go ahead, we'll only be saying hydrogen chloride, and no one will tell you now the valence is this, the symbol is this. So you need to practice, and the more you practice, the easier it becomes. Can someone do for me number 9?
Ammonia is made up of nitrogen and hydrogen.
Please go ahead. That is Jovia.
Yes. Ammonia is made up of nitrogen and
Ammonia is made up of
nitrogen and hydrogen. So you write the symbol for nitrogen, hydrogen, then the valence of nitrogen is 3, and the valence of hydrogen is 1. So you interchange the valences and you get NH3.
Jovia, please go ahead.
Then you get NH3.
NH3. Okay, thank you very much. So I hope all of us have been reminded when we looked at bonding, we said that when nitrogen reacts with hydrogen, we get a compound called ammonia.
Yeah.
So you need to know that not all the times we shall remind you that when I say ammonia, it's a compound of nitrogen and hydrogen, but we've been reminded today that when we talk of ammonia, that's a compound between nitrogen and hydrogen. So you write the valencies. Nitrogen has a valency of 3, and then hydrogen has a valency of 1. So your final compound is
Ammonia.
NH3. Someone is saying, I thought that ammonia is a gas and not compound. Of course, gases can be compounds as well. So ammonia is a compound which is gaseous in nature. Can I get someone taking us through number 10? Someone taking us through number 10? We need to check the table of our notes. We gave the formula of some of the formula of some of those gases. I can't get the person talking. Anne Grace, can you give me the answer? Anne Grace?
So sulfur dioxide, we first start by writing the symbols of the elements found in it, which are sulfur and oxygen. The symbol of sulfur is S. Oxygen O.
Yes.
So we write their valencies. The valency of sulfur is 4. And the valency of oxygen is 2. So we interchange the valencies.
Yes.
So it will be S.
And then?
So the valencies can be divided, so we get a common factor like 2 and divide them, both of them by 2. So by 2, then there is 2. So BSO2.
Thank you very much. Now, I need to note that sometimes the gases, their formula can be hard to write, especially the valencies that they use are not the usual valencies. I hope you note that here, sulfur is using a valency of 4, yet it is not the usual valence. We know that sulfur is supposed to have a valency of 2. Now, from the name, you can easily write the formula. If they say sulfur dioxide, sulfur is S. Di means 2 oxygen atoms. So the formula for sulfur dioxide right away from the name, even if you don't use the valency, it would be SO2. This also takes us to carbon dioxide. When they say carbon dioxide, carbon is C, then they have said it is dioxide, meaning that the oxygen atoms are also 2. So that is why we write carbon dioxide as CO2. So sometimes we may not use the actual way of working out, especially when it comes to the gases. And we gave you that table in your notes. You can check in your notes and you'll be able to see that. So for carbon dioxide, if they say carbon, the symbol is C. Then monoxide, that means it is 1 oxygen atom. So we write carbon dioxide as CO. I'm seeing some people putting up their hands. If there are questions, please go ahead and ask.
Excuse me, teacher.
Yes.
What is the difference between a peroxide and a dioxide?
Thank you. Can I get a response from one of the girls? What is the difference between a peroxide and a dioxide? Can I get an answer from the girls?
Teacher, peroxide had excess oxygen.
I can't get you well. Please speak up. And probably you get a quiet background. Please go ahead. I think I can't get that person. Any other person responding?
And there is Karen. Karen, unmute and go ahead.
A peroxide is made is made under like limited supply of oxygen. I it's made under a limited supply of oxygen. Then a dioxide is just okay. It's just when like both of the elements have a two with them, like they both have a two, something like that.
So I think a peroxide is when oxygen atoms are bonded together, while a dioxide is when two oxygen atoms are separate.
A peroxide has
Okay,
Can I
thank you.
try?
Yes,
Teacher, can I try?
yes, you're the last one.
Okay, a peroxide is formed when
Yes, you're the last one. Then we give you an answer. Go ahead.
okay, a peroxide is formed when burnt in a presence of a lot of oxygen, while a dioxide is like it consists of two atoms of oxygen. No, yeah, two atoms of
Okay,
oxygen.
thank you very much. Thank you very much. Most of your points have an element. I'm going to say something small, then your teacher will continue. A peroxide, now, it comes from a radical called a peroxide. Those are two oxygen atoms with a valency of 2. Now, a dioxide comes from an oxide radical. An oxide radical is oxygen, one oxygen atom with a valency of 2. Now, when an oxide combines with an element with a valency of 4, for example, manganese 4 oxide, or let me say carbon, assuming that I'm going to bring in carbon with a valency of 4, or manganese 4 oxide. I would say carbon has a valence of 4, oxygen has a valence of 2. You see, it's coming from an oxide, I'm dealing with a dioxide. That means 2 comes here, 4 comes here. This will give me C2O4. We get the simplest ratio, which will give us CO2. Now, when you have 2 on oxygen, when it has not come from a peroxide, we say it is carbon dioxide. If we have like a peroxide now, any compound that comes from a peroxide, peroxides are mainly formed with compounds with a valency of 1, most of them. So I'm going to take an example of sodium. We can have sodium peroxide, hydrogen peroxide. Most of the stable peroxides that you come across, you find that the radical is attached to a metal with a valency of 1. So the 2 comes here and the 1 comes here. This will give me sodium with a 2, and but remember this O2, this 2 is part of the radical, so we won't cancel it, and the 1 comes here, but we said we don't write ones in chemistry, so I'll cancel it. So later we said this is sodium peroxide because it has come from a peroxide radical. Then since this other compound on the right hand side has come from an oxide and there are 2 oxygen atoms, then you can say it is a dioxide. So a dioxide is always given to a compound, that name is given to a compound where we have 2 oxygen atoms but they have come from an oxide. Okay, that's what I would say about the difference between a peroxide and a dioxide. Have I answered your question? I think you've understood now.
No.
You've not
Yeah,
understood.
yes.
low,
Teacher,
very
But
low.
You
We
repeat
cannot
what a peroxide is. A dioxide.
Okay, in simple terms, a peroxide comes from a peroxide radical, sodium peroxide. It's starting with a peroxide radical. Then a dioxide comes from an oxide ion or an oxide radical.
I hope that's okay. Generally, when we talk of the peroxide, it is a radical whose symbol is O2. Then it has a valency of 2. Just like the teacher has emphasized, dioxide, it means there are 2 oxygen atoms that are combining with that element. So for example, carbon dioxide, there are 2 oxygen atoms combining with carbon. Then the peroxide, actually even when we are naming, if I want you to write for me the formula of sodium peroxide, I will say sodium peroxide. That means you're going to use O2. Then for oxide, we usually put oxygen atom. Then that 2 usually comes from the valencies that you are going to use. I don't know if that is okay for us. If it is, I need someone to do for me number 12. Do I have questions or any more questions?
Teacher, I didn't get
And
carbon
Grace, do you want to
monoxide.
give me an answer?
No, teacher, question.
Carbon monoxide. Carbon, we said carbon is C. Then when they say monoxide, that means 1. Mono is 1. So you write 1 oxygen atom, just like that, CO. But all of them are capital letters.
Okay, thank you, teacher.
Someone else said they had a question.
Yes, teacher.
Who said they had a...
Yes, teacher. Yeah, I have a
Yes.
question. Excuse me, teacher.
Yes.
I didn't
Yes.
understand the other part for sulfur dioxide. I didn't understand why a valency of 4 on sulfur.
Now that is why we simplified and said gases, when you look at the name for the gas, you just write it the way it is. Because sometimes they use rare valencies. So when we say sulfur dioxide, you simply write S for sulfur, and then dioxide, you put O2. So it becomes SO2. That is the simplest that you can get. You leave out the bit of valence, and I have said you refer to the table that is in your notes where they are summarizing the formula of different gases.
Excuse me,
Okay,
teacher.
thank you, teacher.
Yes, please.
Teacher, according to
They were saying,
the table that they gave us, as a value.
no, I have said refer to the table where we are showing the formula of gases, not the formula of valencies.
Oh, okay, teacher.
There's a table which is showing the formula of gases. So I hope that is fine for us. I want someone to do for me number 12.
Excuse me, teacher.
Yes, please.
I wanted to ask 2 questions.
Question 1.
Is it possible for 2 compounds to have the same formula?
No.
Okay. And then in that table of gases which you gave us and for the radicals, realize that the formula of a nitrogen and one of nitrogen side, they are the same. So how can you differentiate them when
You're saying the formula of a nitrite and then the formula of nitrogen dioxide.
yes.
Now, a nitrite is a radical and it has a valency of 1. So, and we said radicals cannot exist on their own. So usually you'll find like someone saying, write the formula of sodium nitrite. So a nitrite cannot be alone because it has to be with another element since it is a radical. Now when it comes to nitrogen dioxide, just like we have just explained, it is a compound between nitrogen and oxygen. So the formula is NO2 and it doesn't have any valency because for it is a compound. So that is the difference between the two. One is a compound, the other one is a radical. The compound doesn't have a charge or it doesn't have a valency, while the radical has a valence. And then the radical cannot exist on its own, it must be combining with something else. Is that okay, young lady?
Yes, teacher, I've understood. Thank you.
You're welcome. I want my answer for number 12, young ladies. Number 12. Laureen, can you go ahead? Laureen? Laureen, are you there?
Yes. I have forgotten my hand up.
Can't you give me the answer now that your hand is up, Laureen? Can't you give me the answer for number 12? We are going to do it together, so don't go off, Laureen.
Let me try.
What is the symbol of iron, Laureen?
FE.
The symbol of a sulfate?
SO4. Yeah.
We are now moving to valencies. What is the valency of iron? Laureen, what is the valency of iron? Okay, can I get someone responding? What is the valency of iron?
In this case, it's 2.
We have been given 2.
In this case, it is 2 because they have told us it is iron 2 sulfate. Okay, what is the valency of a sulfate?
2.
It is 2.
It is also 2. Okay, we interchange. So finally, our formula will not have anything because we said that 2's are going to cancel out, isn't it? Can I have any questions, young ladies? Because we should complete this list on our own. Can I get someone doing for me number 16? Number 16. I want number 16 from someone. Okay, and I'll give
Should I put down my hand?
Okay, I have seen, is it Joy? Joy, can you respond? Joy Angel.
Aluminium is Al and
Yes,
hydroxide is OH.
yes.
Aluminium has a valency of 3 and hydroxide has a valency of 1. So we interchange the valencies.
Okay, proceed.
To have Al1 and OH3, since 1 is not in chemistry, it's AlOH3.
Okay, thank you very much. That is our formula. I think I should just get a few questions. Our next lesson, we should be looking at equations. I think we have given ourselves some good practice. Number 13, we need to make a correction there on that name. It should be lead 2 nitrate because lead has more than one valence. So we need to specify and write there lead 2 nitrate. So if you have a question, please ask your question. And my advice is you need to try as many examples as possible. Because we are now going to move to equations, and yet equations require that you know the formula of the compounds which are reacting. Nasuna?
Yeah, sorry, I forgot my hand up.
Okay, Jovia? Jovia? Do you have a question?
No.
We have a question.
Kadu? Kadu, can you ask your question?
Is hydrogen carbonate the same as a hydrocarbonate?
Kadu? Is hydrogen carbonate the same as?
a hydro? Is it the same as a hydrocarbonate?
Hydrocarbonate. They are not the same, When we say hydrocarbon, hydrocarbon is a group of compounds that are made up of hydrogen and carbon only. So there are many compounds that we refer to as hydrocarbons, but the definition of a hydrocarbon, it is a compound that is made up of hydrogen and carbon only. Then hydrogen carbonate is a radical, which is HCO3. So the two things are different from one another. Is that okay, Kadu?
Yes, thank you.
You're welcome. I think I should get one last question and we complete with that. I'm seeing the two of you putting up your hand. Daphne?
I wanted to ask if nitride the same as nitrogen.
I can't get you well.
Okay, I'm asking that is a nitride the same as a dinitrogen?
A nitrite, the same as a dinitrogen? Not really. We said a nitrate is a radical, and that radical is NO2, and it has a valency of 1, and that valence is negative. Now, meaning that it gains electrons.
A nitride.
Why? Yes? A nitrite and
Teacher, a nitride. Nitride.
a nitride. Oh, thank you. A nitride is nitrogen which has received 3 electrons. So they are different. Nitrate has NO2 and it has a negative charge of 1. Then a nitride is nitrogen that has received 3 electrons. If you remember when we looked at becoming positively charged and negatively charged. So the one on top here is N3 negative, meaning that it has gained 3 electrons. Then when it is NO3, that is a nitrite. NO2 is a nitrite, and then NO3 nitrate. So they are different things altogether. Is that okay?
Yes, teacher.
I think I need to wind up the lesson. I want to thank you, especially those that have participated in writing the formula of the different compounds. Thank you very much. And I want to encourage all of you, please take your time and practice. How do you write the formula? When someone says this compound, can you write it? And I also told you that in that revision book that you received in S1, there are so many compounds where you are expected to write the formula. So you need to take, we get better. Enjoy your lunch and have a good afternoon.
Thank you, teacher.